So imagine for a second that you are like an undisputed giant in your industry. You know, you completely own the market.
Right, you're the absolute big player.
Exactly. And you're looking out at the horizon, completely confident that you know exactly who your competitors are. You know their roadmaps, you know how much money they have in the bank.
You've got the whole board mapped out.
Right. And then, I mean, for whatever reason, you just happen to look straight up and you realize there's a competitor you didn't even know existed, and they are already in orbit.
Yeah, it is, it's the defining shock to a system, a true Sputnik moment.
It really is.
It's that sudden, terrifying realization that the entire technological center of gravity has just shifted completely without you noticing.
And that is really the only way to describe what happened in January of 2025. I mean, out of nowhere, this new app displaced ChatGPT at the very top of the App Store.
Just overnight.
Literally overnight. And the financial fallout was immediate. In a single day of trading, NVIDIA's stock plummeted 17%.
Which is just a staggering number to even think about.
It was $600 billion in market cap, just erased, like gone. Because the market suddenly looked at the landscape and realized its core assumption about the future of artificial intelligence might be, well, completely wrong.
Right, and that assumption being that building frontier AI requires, an infinite supply of American venture capital.
Yeah.
And an endless supply of the absolute newest, most expensive American hardware.
Exactly. Okay, let's unpack this, because today our deep dive mission is exploring this really fascinating piece from Tech Reader magazine.
It's a great piece.
It really is. It was published today, actually, June 23, 2026, by Aaron Rose, and it's titled DeepSeek, the AI model that was built while the world looked elsewhere. And our goal here today is to kind of deconstruct this myth of the overnight success, right? We want to show you, the listener, how a parallel decade of AI development quietly built a titan.
Yeah, because it definitely wasn't overnight.
Right. But to understand the shock of January 2025, we really can't start at the finish line. We have to rewind to when these parallel tracks were actually laid down, which is around like 2015 and 2017.
Right back to the beginning?
Yeah, when the US and China were running two completely different races, and honestly, they weren't even looking at each other.
No, not at all. They were playing entirely different games with completely different rule books.
So let's look at the US track first.
Sure. So if you look at the U.S. track, the milestones are largely driven by private enterprise and academic ideals. Like in 2015, OpenAI is founded in San Francisco.
Originally structured as a nonprofit, right?
Exactly. With this stated mission to develop AI for the benefit of all humanity. And then jumping to 2017, researchers at Google published this paper called Attention is All You Need.
Oh, which introduces the transformer architecture.
Yes, the famous transformer.
And we should probably briefly explain what a transformer actually is, just so everyone's on the same page, because it's basically the engine of everything we're talking about today.
It's the core of it all, yeah.
So before 2017, AI read text linearly, right? Like word by word. And it would basically forget the beginning of a sentence by the time it reached the end. But a transformer architecture allows the AI to look at an entire sentence or even an entire book all at once.
Right, weighing the context and relationships of every word simultaneously.
Exactly. It's the technical foundation for ChatGPT and eventually DeepSeek.
Right, so the American timeline is really defined by these brilliant researchers' nonprofit ideals that eventually, shift into massive venture capital.
Definitely.
And these foundational technical breakthroughs like the transformer. But over on the Chinese track, the development wasn't driven by a couple of scientists tinkering in a Silicon Valley garage. It was state-level industrial policy.
Right. The article mentions the Made in China 2025 plan.
Yes, exactly. In 2015, the Chinese State Council published that plan, officially identifying AI as a core national strategic priority.
Just flat out saying this is what we're doing.
Right. And then in 2017, which is the exact same year, Google published that transformer paper. China issued the New Generation Artificial Intelligence Development Plan.
Which was, what, a strategy to achieve total global AI leadership by 2030?
Yes, a comprehensive, massive strategy.
Okay, but I mean, let's be real. Government memos get published all the time, A memo doesn't write code.
True. A memo itself doesn't write code. But this memo triggered a massive mobilization of actual resources.
Okay.
It wasn't about Beijing micromanaging engineers in a lab. It was about creating a deeply subsidized institutional ecology.
Ecology, right.
Yeah, think of the U.S. approach, like planting seeds in the wild, right? Just hoping the strongest survive the harsh elements of the free market.
The classic startup grind.
Exactly. China decided to build a massive state-funded mega greenhouse. So if you were an AI researcher in China around 2018, you suddenly had access to subsidized compute.
Oh, wow.
Yeah, local governments provided these grants that essentially allowed startups to buy processing power at a fraction of the market price.
Which, I mean, that changes the entire math of starting an AI company, doesn't it? Considering computing power is by far the biggest operating expense.
It changes absolutely everything. You also had access to below-market real estate in these designated AI research parks.
Right, designed to just cluster all that talent together.
Exactly. Plus access to oceans of domestic data from Chinese giants. And crucially, and this is a big point, this ecosystem reversed a historical brain drain.
Oh, really? How so?
Well, for decades, top Chinese engineering graduates would emigrate to places like Stanford or MIT, and they would just stay there.
Because that's where the money and the labs were.
Right. But because of this new, highly funded ecosystem back home, the percentage of Chinese AI PhDs choosing to remain in China jumped from roughly 40% to over 70% by 2020.
Wait, I need to stop you there, because this is creating a huge logical contradiction for me.
Okay, let's hear it.
So, if the Chinese government is building this massive greenhouse, right, pumping billions into state-backed giant companies like Baidu, Alibaba, and Tencent to win this global AI race,
wouldn't those corporate giants just crush any small competition? Like, how does an unknown startup like DeepSeek survive, let alone win, in a heavily state-controlled top-down ecosystem that was literally built for national champions?
And that contradiction is exactly the most fascinating part of Aaron Rose's piece. Because DeepSeek didn't emerge from Baidu or Tencent.
It didn't.
No. It wasn't a product of big tech at all. It was actually born out of a quantitative hedge fund in Hangzhou called Highflyer.
Wait, a quantitative hedge fund?
Yes, founded by a man named Lang Wenfeng.
So they were basically algorithmic day traders.
Yes, exactly. And understanding the cultural gap between a tech giant and a quantitative hedge fund explains how they actually pulled this off.
Okay, break that down for me.
Well, companies like Baidu and Tencent are, at their core, consumer product companies, right?
Right. They have users, ads, all that.
Exactly. They answer to shareholders. They obsess over quarterly earnings. They have these rigid feature roadmaps.
Yeah, they're huge ships.
Yeah.
Right. And if a new trend appears, they have to pivot massive teams just to be a fast follower so they don't miss out on revenue. Highflyer had literally none of that baggage.
No product roadmap.
No product roadmap, no consumer focus groups requesting new features. They were a trading firm using artificial intelligence for one brutal, specific purpose.
Which was?
Zero-sum, adversarial market trading.
Man, that is a completely different metabolism.
Completely.
It's like, okay, it's like comparing big tech to a luxury cruise ship, right? They are wealthy, they are massive, but they take 5 miles just to turn around.
Exactly.
And the captain is constantly fielding complaints from passengers about the buffet.
Right, exactly.
But Highflyer was like a Formula One racing team. Small, secretive, zero bureaucracy, and just this total obsession with efficiency.
That's a perfect analogy.
Because, I mean, in high-frequency trading, if your algorithm is 1 millisecond slower than the other guys, you don't just lose the trade, you lose millions of dollars.
Exactly. Every millisecond counts.
But I'm still stuck on one thing. How does algorithmic stock trading translate to building a language model that writes poetry or codes software? Like, they seem worlds apart.
What's fascinating here is that at a mathematical level, they are strikingly similar.
Really? Yeah.
High-frequency quant trading relies on absorbing a massive stream of numerical data to find hidden patterns.
Okay.
And then it uses those patterns to predict the exact next fractional movement of a stock price.
Right.
Well, a large language model absorbs a massive stream of text data to find hidden patterns and predicts the exact next logical word in a sentence.
Oh, wow. So it's the exact same fundamental mechanism.
Exactly. They are both fundamentally just giant matrix multiplications. Liang Wenfeng realized that the same techniques his firm used to beat the financial markets, adversarial adaptation, extreme optimization under uncertainty, were the exact skills needed to train frontier AI.
And because they came from that F1 racing team culture, they treated computing power completely differently than everyone else.
Oh, absolutely. The American tech giants, they treat computing power, or compute, as an infinite resource.
Right. If the code is inefficient, just throw more servers at it. Just buy more.
Exactly. But DeepSeek's engineers were conditioned to treat compute as fiercely scarce. It had to be allocated with surgical precision.
And if we connect this to the bigger picture, it really makes you think. Like for you listening right now, think about your own work environment.
Yeah, that's a good point.
Does having infinite resources make your team complacent? Because here we have a scenario where artificial constraints actually forced a team to be vastly more innovative.
And that obsession with scarcity, positioned Liang for what the article points out, is one of the most consequential gambles in recent tech history.
Oh, the 2021 chip bet.
Yes, the 2021 chip bet.
Let's look at the timeline of that bet because the context is just crucial.
It really is.
So it's 2021, OpenAI is releasing GPT-3, the whole tech world is buzzing, and Liang is quietly using high flyers' massive capital reserves to buy NVIDIA A100 GPUs.
Thousands of them.
Right. Thousands. By the time he's done, it's estimated he accumulated roughly 50,000 of these advanced chips.
And we should be very clear here. He wasn't doing this because he had a sudden, visionary dream to build a ChatGPT competitor.
It wasn't.
No, he was executing a strategic regulatory arbitrage.
Wait, really? So it was just a trade?
Exactly. As a hedge fund manager, Liang looked at the geopolitical chessboard. He anticipated that the Biden administration would eventually enact strict export controls on advanced AI chips to China.
Oh, wow.
Yeah. He saw the regulation coming before the policy was even drafted, and he bought the underlying asset.
That is wild. So by 2022, when ChatGPT actually launches and the world changes basically overnight, the U.S. inevitably bans the export of advanced chips to China.
Right.
But DeepSeek is largely insulated from it. They already had their hardware foundation physically locked inside a server farm in Hangzhou.
Safe and sound.
So what does this all mean then? Was this an act of profound technological vision or just a day trader recognizing an asset whose value was about to be redefined by regulation?
I mean, the motivation was pure day trader arbitrage.
Unbelievable.
But the consequence of that trade fundamentally altered the trajectory of global AI. You see, the U.S. export ban was designed to be a hard ceiling on China's ambitions.
Right, the logic was simple. If Chinese companies can't buy the newest, fastest NVIDIA H100 chips, they mathematically cannot build the best models.
Exactly. But instead of acting as a ceiling, the ban became a forge.
A forge. I love that word for this. Because, if your boss cuts your department's budget in half tomorrow, your first instinct is panic.
Oh, absolute panic.
You assume the project is doomed. But what DeepSeek proved is that starving a system of resources might actually be the only way to force it to evolve.
Right. The American labs were operating under a paradigm of unconstrained scaling. If they hit a technical roadblock, their solution was to raise another $5 billion, buy 100,000 of the newest chips, and just brute force their way through the math.
But DeepSeek didn't have that option.
No. They were locked into a paradigm of constrained optimization.
They had to build the future of artificial intelligence using only the fixed, aging A100 chips they already had in the room.
Exactly. And because they couldn't just throw more hardware at the problem, they had to fundamentally rewire how an AI actually processes information.
And the financial gap this created is just staggering. I mean, according to the piece, in late 2024, OpenAI spent an estimated $100 million just on the computing power to train GPT-4.
100 million.
Yeah. But DeepSeek trained their V3 model in just 2 months, and it cost them $5.6 million.
Which is just, going from 100 million to 5.6 million isn't a marginal efficiency gain. That is an entirely different universe of engineering.
Right. How did they even do that?
Well, they achieved that through 3 specific, highly technical architectural breakthroughs.
Okay, let's break this down. What's the first one?
The first is called MOE, or Mixture of Experts.
Okay, and how does that work in practice?
So in a standard brute force neural network, every time you ask the AI a question, every single parameter in the massive model activates to process the data.
Oh, wow. Even the irrelevant stuff.
Everything. It requires a tremendous amount of floating point operations, or FLOPs,
right,
which consumes massive, massive power.
Right, which costs money.
Exactly. MOE drastically reduces that computational load. It only activates the specific tiny subset of expert parameters needed to process a given word or token,
leaving the rest of the network basically dormant.
Exactly.
So, to use an analogy, imagine a massive corporate headquarters with 1,000 employees, right?
Okay.
The U.S. brute force method is forcing all 1,000 employees to drop what they're doing and attend every single meeting just in case someone asks a question they happen to know the answer to.
Which would be a nightmare.
An absolute nightmare. DeepSeek's MOE architecture is like a smart manager saying, no, this meeting is about tax law. We're only calling the 5 specific tax accountants into the room.
Right. And everyone else just keeps working.
Exactly. It saves an unbelievable amount of time and energy. Okay, so what was the second breakthrough?
The second was MLA, or multi-head latent attention. And this addresses the memory cache bottleneck.
A cache bottleneck, right?
Yeah. So when an AI generates a long response, say 1,000 words, it has to hold the previous 999 words in its active short-term memory to ensure the next word makes grammatical and logical sense.
Oh, right. That's called the context window, right?
Exactly. The context window. Keeping that window open requires immense memory bandwidth, which those older chips at Liang and stockpiled really struggle with.
How did they fix it?
MLA essentially acts like a highly efficient zip file for that active memory. It compresses the cache, allowing the model to run incredibly fast, even on the older hardware.
That's brilliant. Like just zipping the file as you go.
Exactly.
Okay, and the third breakthrough, because this one seems to be the most crucial for their actual reasoning abilities.
Yes. The third is RLVR. That stands for Reinforcement Learning with Verifiable Rewards.
Okay, and to understand why this matters, we have to look at how American labs typically teach AI to reason, right? They largely use RLHF.
Right. Reinforcement learning from human feedback.
Right.
And RLHF requires armies of human workers manually reading the AI's outputs, grading them, and telling the AI which answer is better.
Which has to be insanely expensive.
Insanely expensive, incredibly slow, and, honestly, prone to human bias. DeepSeek replaced those expensive human graders with objective math and code verification.
Right, because 2 + 2 = 4, regardless of a human's opinion.
Exactly. They built a training system where the AI generates chains of logic to solve a problem. If the final mathematical proof is correct, or if the software code actually compiles and runs without errors, the system automatically verifies the reward.
Oh, wow. So they completely eliminated the bottleneck of human subjectivity.
Completely. The AI was forced to teach itself pure logic based on objective, verifiable constraints.
And all of these constraint-driven innovations, MOE saving processing power, MLA compressing the memory, RLVR automating the reasoning training, they all just compounded.
They stacked on top of each other.
Which brings us back to that Sputnik moment on January 20th, 2025.
The launch.
The launch. DeepSeek launches the R1 model, and it benchmarks right alongside OpenAI's absolute elite reasoning model, O1. But because of its architecture, it costs 90% less per query to operate.
90%.
Right.
And that price collapse is really what triggered the market panic.
Oh, for sure. But it wasn't just the price, was it?
No, it was the distribution method. DeepSeek didn't put R1 behind an expensive corporate paywall. They released it open weight under a highly permissive MIT license.
Right, and we should definitely define that because it's literally the weapon that disrupted the whole industry.
Oh, absolutely.
An MIT license essentially means anyone can take the underlying code, use it, modify it, and even commercialize it for free.
Free of charge.
And the model was so lightweight and efficient that within a few days, amateur developers were installing it on $50 Raspberry Pi computers in their bedrooms.
Which is mind-blowing.
It is, but we have to look at the immediate geopolitical reaction to this because it wasn't all just cheering from developers.
Right. The fallout was severe. I mean, within a week of launch, multiple U.S. states, Taiwan, Australia, and eventually the U.S. Navy banned or heavily restricted the application on their networks.
Wow. Just shut it down.
Yeah. And the Tech Reader article is careful to note that there were, substantive security concerns driving these bans.
Brett, we have to be clear about that. We aren't taking sides here, just reporting what the sources point out.
Exactly. The concerns were real. All of the DeepSeek app's user data was physically stored on servers within China.
Okay. Yeah, that's a big deal.
And furthermore, the model itself was hard-coded to enforce Chinese government censorship policies regarding politically sensitive topics.
So basically, a foreign government's censorship rules were suddenly operating on millions of Western smartphones.
Precisely. But, alongside those legitimate data privacy and security concerns, the swiftness of the bans also reflected a much deeper institutional panic.
Right. The realization that a Chinese competitor hadn't just matched Western capabilities, they had captured the Western mainstream consumer market basically overnight.
Yes.
But, here's where it gets really interesting. This open source strategy is the puzzle piece I keep coming back to.
It's the wild card.
Yeah. Why would Liang Wenfeng spend millions training this model just to give it away under an MIT license? I mean, is he some philosophical champion of free open source technology for humanity?
Not at all. As Aaron Rose argues in the piece, this was calculated, asymmetric institutional warfare.
Warfare. Okay, explain that.
You have to look at the economic incentives. In the United States, companies like Microsoft, Amazon, and Google generate billions of dollars by renting out access to their closed, frontier AI models.
Right, through their massive cloud infrastructures.
Exactly. The entire American tech ecosystem is built on software as a service, or SaaS, revenue.
They act as toll booths.
Yes, toll booths.
Like if a startup wants to build an AI tool, they have to pay a toll to OpenAI or Google every single time their app generates a word.
Right. But China's domestic tech economy isn't structured around enterprise cloud SaaS. It's heavily skewed toward consumer apps and e-commerce.
Ah, I see.
So Liang Wenfeng didn't have a massive domestic cloud revenue stream to protect. So by giving a frontier-level reasoning model away for free, he essentially detonated a bomb underneath the American business model.
Because, I mean, if you're an independent developer or a mid-sized corporation, why on earth would you sign a contract to pay OpenAI millions of dollars a year to rent their intelligence when you can literally download DeepSeek's comparable intelligence and just own it forever for free?
It makes no sense. It immediately undermined the astronomical valuations of OpenAI, Anthropic, and Microsoft's AI divisions. And furthermore, weaponizing open source made the geopolitical response practically impossible to enforce.
Right.
I mean, you can easily ban a corporate app from the Apple App Store,
Right.
but you cannot effectively ban a distributed Git repository.
And a Git repository, just for context, is essentially a public digital library for code. Once the blueprints are published there, developers all over the world can check them out, download them to their local machines, and just start modifying them.
Exactly. The open source community, which includes thousands of American researchers, by the way, simply took the R1 code and started building new products on top of it.
You can't put the genie back in the bottle.
No. A government can block a web domain, but they can't delete an idea that has already been downloaded onto 10,000 offline laptops.
Man, it was the ultimate asymmetric disruption.
It really was.
So, kind of bringing this full circle back to the original source, the article cites the Stanford AI Index 2026 report, which concludes that Chinese companies have effectively closed the AI performance gap with their U.S. rivals.
Yep, the gap is closed.
And this wasn't a sudden overnight magic trick. It was a decade of parallel tracks. One track was fueled by endless venture capital and unconstrained hardware access, basically operating under the assumption that bigger is always, always better.
Right.
And the other track was fueled by state-level industrial policy, but ironically executed by a hedge fund with a ruthless zero-sum discipline of constraint.
And in 2025, those tracks finally crossed.
They really did.
Which leaves the industry with a looming, almost existential question moving forward. And it's actually a question Liang Wenfeng himself has hinted at.
Oh. What is it?
What happens when the constraint is finally removed?
Oh, wow. Okay.
Right, because DeepSeek became incredibly efficient because they were starved of the newest hardware. They were locked in that room with those aging chips.
Right.
But if geopolitical tensions ease and export bans are relaxed, or, if China's domestic semiconductor industry finally catches up to NVIDIA and DeepSeek suddenly gets access to infinite computing power, what happens then? Will they retain that brilliant F1 racing team culture of efficiency?
Or will they inevitably devolve into just another bloated, unconstrained scaling machine with no off switch?
Exactly. Suffering from the exact same institutional bloat as the American labs.
That is the defining question for the next decade of AI, honestly.
Wow.
And it leaves you, the listener, with something provocative to mull over today. We constantly assume that whoever has the most money, the biggest budget, and the most resources is guaranteed to win the race. But think about the life cycle of innovation in your own life.
Yeah, it's universal.
If extreme artificial constraints are what actually forge superior, highly efficient technology, are the incredibly well-funded, resource-rich leading companies of today practically dooming themselves to stagnation?
It's a scary thought for them.
It really is. Can extreme wealth actually be a fatal disadvantage in the tech sector? The next time you look up and see a competitor in orbit that you didn't even know existed, ask yourself, did they get there because they had more fuel to burn?
Or did they get there because they were forced to build a lighter ship?
Exactly. Thank you for joining us on this deep dive into the forces shaping our future. Keep questioning the narratives behind the world's biggest leaps, and we'll see you next time.